Here we have a prototype of my latest Loadbank design. It's just a Loadbank controller in this case. Now there's currently 10 nodes hooked up on here. There's 4 on here, and there's 6 on the table. Now each has an array of 8 LEDs to act as channels. Now this board here has 4 nodes on it, only one set of LEDs, because this is mainly designed for the enumeration of the swarm rather than actual Loadbank simulation. Now, anyway, let's get this fired up and show you how it goes. So it instantly found all 10 nodes, but in cases of a noisy environment it may not find them all in one go. So what it does is it tells you how many nodes there are and the maximum number of kilowatts needed that can be provided. And basically I enter how many kilowatts I want. Okay, so 1, 2, 3. It's 123 kilowatts, and if I press the button on there, that basically lights up, tells me which channels would be used in the swarm. Now, another thing with this system is if you want to use the maximum, you just basically stick all 9s and it puts it past the highest, so it automatically gives the highest number on there, and then I hit the accept button. Then all the channels come on in the swarm, and then to demonstrate the stop features, that we have safe stop and emergency stop. The safe stop steps channels down one at a time to stop tripping breakers, to safely stop it. Okay, I'm going to hit that. Oh, just to note, the way the channels are laid out on these boards, the most significant bit is to the right, or the highest value channel. Okay, so I'm just going to accept that again, so it turns them all on. Now, the emergency stop feature, what that will do is it will shut everything down, and it will freeze every single unit in a state where it has to be powered off to be used again, as a safety precaution. There. So I'll accept no more commands. Okay, so let's power cycle that to burn. Okay. Now the count and delay can be modified to make it shorter if you're not expecting too many nodes. That's something I've got to add into the future. Now currently we're using the waterfall distribution method, where it will fill up the first load bank, then spill over to the next one and the next one, and so on. And for a safety precaution, it then sends a clear to all the other load banks inside the swarm. The other method which I'm working on right now is called the unified table array, which basically the system during enumeration gets all the specifications for each single node, and it will add it together into one huge table and treat the entire swarm as one single load bank with as many channels as needed. As many channels as it has. In this case, with that version of the software running, this would be an 80 channel load bank for one single unit in its eyes. Okay, that's it for now. what we have here is a CAN to USB interface. It's all isolated right here. This is a prototype, of course. Basically acts as like a pass-through. You stick on the CAN bus, you can choose whether to take power from the CAN bus, or you could jumper these and take power directly from the USB instead.